maximum dimensions and volume. Like I said in the introduction, I'm going to focus on a cuboid. There are many shapes that can be analyzed and that can be modeled using differentiation. But let us look at this simple example. A rectangular box open at the top has a square base. The internal side of the base is x centimeter long, and the total internal surface area of the box is 432 square centimeters. Express in terms of x the internal height of the box. Now, here we have the box. In the question, it has been stated that the box is open at the top. And if it is open at the top, and then we cut the edges. These edges here. That let me use that it's open. We cut these edges here. Cut them. The edges there that are heights. Cut those edges. Then we open. It's going to form something like this diagram. Now, from here to here is h, and that will be reflected here. The base is x, and this is x throughout. X, that is x, that is x, and that is x. So that is the material, the internal dimensions. And the question has stated clearly that the surface area, total surface area of the internal dimension is 432. So take this, add this, and you add this plus this. The total surface area must add up to 432. But then there are four figures here which are the same. Look at this. Look at this one. Let me use a pointer and look at this box here. This has h and x. Look at this. This one has h and x. Look at this and this. So how many are they? 1, 2, 3, 4. So there are four shapes which are the same, have the same dimensions. So that means the area of all of these four is just the same as 4 times the area of one particular shape. Now what is that shape? Maybe that is a rectangle. Yeah, that is a rectangle. Now the dimension of this is x times h. So for us to get the area of this is just length times width, which is h times x. But there's this one here at the center, which is the base. That's x times x. So the area is x times x because the length is x and the other length is x. So look at it. Total area x times x plus 4x times h. Why are we saying x times h? This is x and then this is h. Why are we multiplying by 4? We are multiplying by 4 because they are 4. 1, 2, 3, 4. We have 4 figures which are alike. So simplifying it further, we have been told that the total area is 432. Simplifying it further, you realize that the total area 432 is equal to x squared plus 4xh. But the question is demanding that we express h in terms of x. Express in terms of x the height. So this height, you're going to make this height the subject of the formula. So let us go to the next slide and look at how we do the manipulations. So from doing the manipulations there, take this to the other side, okay, and then you take further to the other side, you divide by minus 4x, you come up with this, h is equal to 1 or 8 over x minus a quarter x. Now from the indices, maybe we can try to revise some little bit of indices. 1 or 8 over x is the same as 1 over 8x power minus 1. So we just removing this fraction there so that it can be dealt with easily. Minus 0.25x, because 1 over 4 is the same as 0.25. So this is how we can express h in terms of x. Now we have seen how we are supposed to express the height in terms of x. The question will guide us on what to do next. Let us look at what you're supposed to find. The internal volume of the box. Now, from the basic measurement knowledge, we should be able to know that the volume of a cuboid is given by base area times height, or the volume of any particular prism, because a cuboid is a prism, is base area times the height. So the base area, this base area here, where is the base area? Let us go back to the diagram. The base area, this is the base area, x times x times x squared. So the base area is x squared. The base area times the height will give us the volume. But what is the height? We have to, this is x squared, so base area is x squared, here is x squared. We have to substitute the value of h, which contains x's only. We already found the value of h in terms of x, so we are going to replace it with x's. It is very important. So after replacing it with x's, open the bracket, x squared, you come up, it boils down to 108x minus 0.25x cubed. So that is the expression of volume in terms of x. So we want to just use x. Now, you can guess what is coming. Maybe try to guess what is coming. In a few moments, we are going to do what we are supposed to do in this topic, and that is we are going to differentiate that. Let us see how what the question will tell us. Find the value of x for which the volume is maximum. The moment you hear this word maximum, that should tell you that the gradient function is equal to 0. So dv with respect to x. Remember here v is volume. Don't confuse this v with the velocity one. This is volume in this particular example. And this x is the dimension. Okay. So since we have volume, when the volume is maximum, the dv dx is 0. But we have our expression of v. The expression of v is already there. We need to differentiate it. So differentiating, I think after you have known how differentiation takes place. It boils down to 108 minus 0.75x squared. And then what is the value of x? The value of x, from that, the value of x is 12 centimeters. You can also get a positive or a negative. So we are not going to use the negative, we are going to use the positive because a dimension cannot be negative. So the value of x is 12 centimeters. Let us look at the next question. Find the maximum internal volume of the box. Now, our function here This is the last part. So let me finish up. Let me finish up. This is the last part. So our function here, the function is v is equal to 108x minus 0.25. And we have already found that the value of x is 12 when this v is maximum. So we are going to substitute the value of x in this function of ours. So find the maximum internal volume of the box. So substituting for 12. And then we come up with 864 cubed centimeters. That marks the end of this video tutorial. Thank you for your patience. Let's meet in the next tutorial, and that will be on integration. Thank you.